Alright, now welcome to part 2 of this video, and in this video we are going to be talking about the terms used in wave. This part is very important. Before we begin to talk about the terms that is used in wave, first of all let me draw a representation of a wave motion. Already a wave oscillates, yes, all wave undergo what is called oscillation, right? Now the distance, are we getting it now? Now, from this point to this point is what we call the amplitude. So I will represent that by A. From this point to this point, we'll explain this later, is what we call wavelength. Are you getting it? Now, this highest point, like this highest point of oscillation, this highest point, not this is not the highest point. This top is the highest point. This place is the lowest point. This top is the highest point. This place is the lowest. The highest point is called crest. Listen very carefully. And the lowest point is called trough. Are we getting it now? The highest point is called crest, and the lowest point is called trough. Now, how do you get one complete cycle from a wave? From this point to this point is a half cycle. From this point to this point is another half cycle. Look at it. When I bring this out now, it looks like a semicircle, right? If I bring this out also, it looks like a semicircle. So if I join those two cycles together, there is a complete cycle. So that is one oscillation or one cycle is from here to this point. Are we getting it now? We'll begin to explain those as time goes on. So the first thing we talk about is called amplitude. Amplitude. What is amplitude? Amplitude is defined as the maximum displacement from rest. The maximum displacement from rest or its equilibrium position. Are we getting it now? Or you can say is the distance from the point of rest to the highest point of oscillation of the wave is called amplitude. So from here to here, the distance from here to here is amplitude. Are you getting it now? From here to here is amplitude, from here to here is amplitude. The distance is the same, represented by A. The next thing we talk about is crest. You already know crest, no need for me to write it. Crest is the highest point of oscillation. Are you getting it? Is the highest point of oscillation. While trough is defined as the lowest point of oscillation. Are we getting it now? So these are crest. These are crest. Why these are trough? Are we getting it? Now, after crest and trough, we begin to talk about frequency and period. What is frequency? Frequency. This thing is very important, and it is measured in hertz. Frequency, are we getting it? Frequency. Now, listen, as this pattern occurs, it means that the wave was oscillating. Now, let's imagine a snake, God forbid, moving like this, right? Moving like this. I'll have another one moving like this. Now, frequency is defined as the number of oscillations performed in 1 second. I told you that an oscillation is from here to here, right? Now let's say a wave took 5 perform 3 oscillations. 3 oscillations will be 1, right? 2, 3 in 1 second. Another wave perform 2 oscillations in 1 second. That is 1, 2 in that 1 second. It means that the first one have higher frequency than the other. So frequency is defined as the number of oscillation per unit time, or number of oscillation in 1 second. Are we getting it now? Now, frequency is measured in hertz. The unit is in hertz. Make sure you write this down, especially this frequency. Are we getting it now? Now, so frequency has a formula. Frequency has a formula. The formula for frequency is equal to F equal to N over T, where N is the number of oscillations. Are we getting it now? Number of oscillations, and T is the time in seconds. So this is the formula for frequency. Now let's take an example. Let's say we have a wave that performs 50 oscillations. 50 oscillations. Are we getting it now? In 5 seconds. Calculate the frequency of this wave. Very easy. You will say F is equal to N over T, right? And we now know that N is equal to 50, so that means 50 will be here, over T is equal to 5 over 5, right? That will be 50 over 5 is 10, so the frequency will be 10 Hz, as easy as that. So the next thing we'll talk about now is period. What is period? What is period? The symbol for period is T, capital letter T. Period can be defined, are we getting it now, as the time taken to perform one oscillation. Write it down, there is no time. As the time taken to perform one oscillation. So if you relate that definition with frequency, you discover that they are inverse of each other. So it means that period, this formula for period is T is equal to 1 over F. That means period is the inverse of frequency. And frequency is also what? The inverse of period. Are we getting it now? Now let's say, for example, we have the equation we calculated just now when we say that N is equal to 50. Are we getting it? And T is equal to 5. Calculate the period of this. What we'll do is that first of all, we can get the frequency to say F is equal to N over T, right? So this is N, 50. That will be 50 oscillation over 5 seconds. Are you getting it? That will be equal to 10 Hz. Now to get the period, that means that period is 1 over 10. Are we getting it now? And 1 over 10 is the same thing as 0.1 seconds. So period is measured in seconds, and it is the inverse of frequency. So let us recap. Frequency is what? The number of oscillations performed per unit time. While period is time taken to perform one oscillation. And period is the inverse of frequency. Also, frequency is also what? The inverse of period. Are we getting it now? Are we good to go? Now let's continue. The next one we talk about is called wavelength. Wavelength. What is wavelength? Wavelength can be defined as the distance, make sure you write it down, between two successive crests or trough. Is the distance between two successive crests or trough. What is a successive crest? This and this are successive. Are we getting it? This and this are successive. But this and this are not successive. It means that crests that are following each other. So this and this are successive, this and this are successive. The distance between them is called wavelength. Distance between them is called wavelength. The distance between them is called wavelength. Are we getting it now? Are we getting it? So wavelength is defined as the distance between two successive crests. Are we getting it? Now the symbol for wavelength is called lambda. The symbol for wavelength is called lambda. Are we getting it now? Now there is a relationship. Alright, now there is a relationship between wavelength, frequency, and velocity. But we did not define velocity, so let's use a short time to define velocity. It's very easy. What is velocity? Velocity is the distance or displacement over time. So the wave speed or velocity, they can be used interchangeably. The wave speed or velocity is the distance moved by the wave per unit time. Are we getting it now? It's represented by V. So the relationship between them is given by the formula V equal to F lambda. You can say that with me. V equal to what? F lambda. You watching it, say it. V equal to F lambda. That is the secret to memorize the formula. Just say V equal to F lambda. V equal to F lambda. V equal to F. The V here is the wave speed or velocity. Wave speed or velocity. It can be used interchangeably in this topic. F is the frequency, and lambda is the wave length. So in the next class, we'll be doing more of calculation on this topic. But before I go, let me drop another formula. There's a formula you need to know. Remember when you were doing simple harmonic motion, we said, we said that F, are we getting it? We said that frequency, let me drop it here, is equal to 2 pi. We said that W, that is omega, is equal to 2 pi F, right? So also know this. So with time, in next class we'll be doing calculations. We'll do Y, jam, and other calculations you might expect in this topic. Thank you very much. God bless you.